We are going to continue in chapter 2 today, starting once again with a misleading statistic. We talked a lot about our last time together. When you have a graph that does not start at zero, the crazy things that can happen, and it looks like certain data is much larger than others. But if you started at zero, you should be all right. But there's something wrong even with this one. Can you check it out and see what is wrong with the vertical scale here? Right? You'll see, correct? It does start at zero, right? But look at the difference. It goes 0 to 1. Then it goes 1 to 2, which is a difference of 1 each time. But then 2 to 4 is the difference of 2. 4 to 8 is the difference of 4. 8 to 16, and so on. So if I said to you, it looks like from 1 to 2 is the largest increase, right? Goes from 0 up to 8. Okay, it looks like a very, very large increase from 0 to 8. But if you go from, for instance, 3 to 4, 3 to 4 is from 4 to 16, that's 12, okay? And the graph does not show 3 to 4 as being the biggest increase, okay? This one looks like it is, so that is extremely misleading. So always check the way your graphs are constructed. Here's another way you can make a misleading graph, is if you do it with perspective, three-dimensional. I mean, the perspective is beautiful from an artist's standpoint, okay? But it appears as though 1995 is the biggest number of singles sold. But if you look at the perspective is that 95 is exactly the same as 97. Now, what about 96 and 98? 96 is actually a little bit bigger than 98, okay? Because it's, go by the perspective here, it is a bit larger. But this is a horrible travesty here. This one is not the biggest. It's the same as 97. 21% of the boys, 30% of the girls support me, therefore I'll get 51% of the vote. Oh yes, you would be shocked at the number of people that think that's probably so, okay? And the other interesting thing I think about this problem, 21% of the boys and 30% of the girls support me, I'll get 51% of the vote. You'd need to know how many boys and how many girls there were and actually do the math to figure it out. Supposing, for instance, that there are 1,000 boys and only, say, 200 girls. If there's 1,000 boys, 20% of 1,000 is roughly 200. If there's 200 girls, 30% of 200 is only 60, even though they have the higher percentage, depending upon how many boys and girls there are. That'll make the final determination as to how many are supporting him. Okay, so you just simply cannot add the percentage. Okay? All right, so we're going to talk about qualitative data today. Qualitative data, remember, is data that is usually not numerical, but you can't do math on it. You can't find averages, so on and so on and so on. So frequency is the number of times a value appears as data. Like, for instance, we're going to go down here to this SU Stat class. We're going to come up with a frequency distribution. The frequency of, for instance, freshmen would be how many freshmen there are. The number of times a value appears as data. Frequency distribution just lists the values, freshmen, sophomores, juniors, and seniors, and their number of appearances. Relative frequency is the ratio of the frequency to the total number. Relative always, always, always deals with percentages. Make that a huge deal in your notes. Relative frequency always deals with percentages. All right, so let's do it. We have freshmen, we have sophomores, and I think I did those with the letter O. We have juniors, and we have seniors. All right, so how many freshmen do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 freshmen. Sophomores are the letter O's. 1, 2, 3, 4, 5, 6, 7. Sophomores. Juniors, letter J's. 1, 2, 3, 4, 5, 6. Seniors, letter S. 1, 2, 3. 3 makes a total of 9 and 19, 28. Got them all. Okay, this is a frequency distribution right here. Okay, relative frequency. So this is the frequency distribution. Now we want the relative, which means we're going to be dealing with percentages. Because we know there's a total of 28, we want to know what percentage of 28 is 12. So it's a division problem, 12 divided by 28, and I get roughly 43%. 7 divided by 28, that's easy, 25%. 6 divided by 28, I get 21%. And 3 divided by 28, and I get 11%. Do they add up to 100? 8, 9, 10, 5, 6, 7, 8, 9, 10. Sometimes they won't add up to 100 depending upon how you round your decimals, but it should be very, very close. This is your relative frequency distribution. Okay, and I keep thinking I skipped. We did that. We want to construct a pie chart for the stat class. Now, I have this nice big protractor, and I don't have it to do this online. Sorry about that. So I made a sample homemade one here that should help us. How are you going to do your pie chart? I would suggest you Google protractor, get a picture of one, print it, and cut it out with a pair of scissors, and you have a nice protractor, okay? All right, so here we go. First thing we're going to do, we need a circle, draw a radius. I want 43% to be freshmen. How many degrees in a circle? 360. So you want, for your number of degrees, how can I do this? For my degrees, I want to take 360 times the percentage. Okay? So I'm going to take 360 times 0.43, and I get 155 degrees. Line up the bottom of your protractor with the radius, and I'm going to come over here to 155 and draw the line up through here. And now, this is students in stat title. This is 43% freshmen. Make sure you put the percentage in the pie graph. You don't put the 155 degrees. Next, we want to take 25% of 360. That's easy. That's 90 degrees. So I just swing my protractor around to this side now, make a mark at 90, draw it down through here. And I have, right here, I have sophomores, and they are 25%, percentage, not degrees. 21% of 360. 21 times 0.21, strike that, times 360 is about 76. 76, I keep turning the protractor to 76 is there. Draw the line, coming down through like this. And I have 21%. This would be juniors. And I should not even have to measure. This should be 11% are seniors. And there's my pie chart. Can everybody see that? Looks pretty good. Okay. This last one should actually be, if you want to double check your work, 0.11 times 360 should be pretty close to 40. And oh my word, I'm pretty close to 40. Yeah. For my poor old homemade protractor, it looked perfect. Using relative frequencies, you get your degrees, but you put the percentages in the circle, okay? Here are some pictures of pie graphs. Notice the percentages for the various pieces of the pie. These are not recommended three-dimensional. The same thing with perspective can cause you problems. At least in this one, they have percentages. This one, they don't have percentages, and that's a problem. This is a coxcomb graph, okay, Florence Nightingale. Many of you remember the famous nurse. She did a lot of things with pie graphs, and she did other things inside each piece of the pie for the months of the year. How many deaths from wounds, how many deaths from other causes, and so on. She was practicing her statistics. All right, some of your questions will look like this. Okay, so let's go through these. And this is going to be a little tricky. Many of you will not be able to see this on the teaching video. If you go to the regular PowerPoint, you can see it a little bit more clearly. But I will repeat those percentages so that we can work these out. All right, so you have a cookie survey done. Peanut butter is here, 19%. Chocolate chip is here, 33%. Oatmeal raisin is the favorite of 30%, and lemon is the favorite of 18%. Okay? Now, if 350 people participated in this survey, how many people like chocolate chip? Chocolate chip is liked by 33%. So I'm going to take 350 times 0.33. And I get about 116 people. So for this one, I would take 350 times 0.33. Change your percentage to a decimal and multiply. If 96 people liked oatmeal raisin, right here. If 96 liked oatmeal raisin, how many were surveyed? This question is like the exact opposite of this, okay? We don't know the total number surveyed. We know oatmeal raisin is 30. I think, did I say 30? 30% is oatmeal raisin. So I know that 0.30 times the number surveyed, which I don't know, should give me the 96, right? So 0.30 times something is 96. Can you multiply? No. You got to divide. 96 divided by 0.30. And there were 320 people surveyed. Okay? Let's go on. When constructing this pie graph, how many degrees were used for lemon? Lemon was liked by 18%. So if it's 18% of the total number of degrees, for lemon, you would want to take 0.18 times 360, or 65 degrees. Okay? Are you sticking with me on these? These are great problems. If 60 people selected oatmeal raisin, then how many people selected peanut butter? Okay? A couple different ways you can do this problem. First, if 60 people selected oatmeal raisin, I know that 30% of the total, 0.30 times the total surveyed, is 60, right? Okay? So dividing 60 by 0.30, 200 people were surveyed. So now, how many selected peanut butter? Peanut butter is 200 times 0.19, and I get 38. 38 people selected peanut butter. Another way you could have done this is we know 30% selected oatmeal raisin. So I know that 0.30 is to 60 as 0.19 for peanut butter is to X. Okay? Is that going to work? I've got, if you cross multiply 60 times 0.19, you get an answer divided by 0.30, and you still get 38. So a couple different ways you can do the problem, but those are great, great problems. Okay, bar graphs. Bar graphs. And I just erased everything, wouldn't you know it? For the stat class. Bar graph displays values on the horizontal x-axis, frequencies on the vertical. The bars should not touch each other. Okay, going back, sorry about this. Let's go back to the stat class. There were 28 people, I can remember that. Freshmen, there were 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. So freshmen, there were 12, total of 28. Sophomores, there were 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 sophomores. Juniors, there were 1, 2, 3, 4, 5, 6. And if there's 28, there should be 13 seniors, right? No, that's not right. Seniors, 1, 2, 3, just the 3, I'm off by 10. Okay, yep, 28. Okay, and the percentages here were 12 divided by 28. What did I get for erasing so quickly? 12 divided by 28 is 43%. I remember that one. 7 divided by 28 is 25. 6 divided by 28 is, and probably don't even have to do this, 21%. And 3 was 11%. Okay. Now, we want to make a bar graph for the stat class. A plain bar graph, frequency bar graph. Now, you will have graph paper, much nicer when you have graph paper. I need to get what's my highest number, 12. So I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Down here, I have freshmen, sophomores, juniors, seniors. The bars do not touch. Okay? I have 12 freshmen. I would go the whole way here up to 12. I have 7, which would be right here for the sophomores. I have 6 for the juniors, which would be right here. Trying to get as close, like I said, graph paper is much better. And for the seniors, title, students in stat, class, and number of students in stat. That's the bar graph. Here are some bar graphs. Okay. Title, identify your axes, bars don't touch, numbers, colors, trash on the beach, numbers, different kinds of trash. Could have been some titles there on the axis. Three-dimensional, we should stay away from those. And here the bars are running sideways. I'd rather if your bars go up and down. Okay? Make the bars go up and down, please. Donut charts are like pie charts, just like we did for the stat class. When you draw your first radius, you're just going to make one pie graph inside of the other one. You will have one of these on your homework, okay? So it's simply doing one pie graph on top of the other one, all right? And drawing your different pieces of the pie as rings. If you have any trouble at all on that, please, please, please contact me. Oh, yes, my favorite donut graph. Oh, yes. Okay, there's your homework. Now, here's the donut graph I talked to you about. Okay, here's all the information. You're going to have, for the favorite dessert, you're going to have students on one ring. You're going to have parents on another ring. I don't care which ring you put them on. All right, but draw a radius and do all of one section first, and then do the other one, okay? And some textbook problems here.